In this video, we can start with the third module. So in the third module, the first topic is machine independent assembler features. Machine independent assembler features means that do not depend on the architecture of the machine, which means that do not depend on the processor. Such features are more related to software than to hardware. The examples are literals, symbol defining statements, expressions, program blocks, and control sections. So in this video, we will learn about the literals, which is a machine independent feature. Literals are actually constants. It is easy for a programmer to write the value of a constant operand as part of the instruction itself. Normally, the constants are defined at the end of the program. For example, if we want to define a character constant, we will use the reserved word byte. Integer constant means we will use the reserved word. Using that, the constants are defined and then that constants are used with the instructions. For example, alpha reserved word 1. This is a definition of the constant. Then we can use LDA alpha. So the constants are defined apart from the instruction. But instead of that, we can directly give the constant as part of the instruction operand. For that purpose, we are using the literals. This literals avoids defining the constant elsewhere in the program and making a label for it. For example, so here this is a constant CEOF, end of file constant. It's a character constant. It is given with the instruction itself as the operand value. And literals are prefixed using the equal to symbol. So here we can see the equal to symbol. Equal to symbol means whatever follows is a literal. And this is the object code for that one. Object code for the literal. Now we can see the difference between a literal and an immediate operand. In immediate operand also, this constant value is given as part of the instruction operand. So here we can see that LDA hash 3. So 3 is a constant. It is given as a part of this instruction. It's not defined elsewhere. So what is the difference between this? One is for literal we will use equal to symbol. For immediate operand we will use the hash symbol. And the main difference is while writing the object code, for immediate operand we will write the constant value in the object code. But for literals we have to write the displacement here. Instead of the value we have to write the displacement. That is in immediate mode the operand value is assembled as part of the instruction itself. In case of literals, the assembler generates a specified value as a constant at some other memory location. The assembler generates the value in some other memory location. So that is the difference. Literal pools, as the name suggests, is a grouping together the literals. So whatever literals we have used in our program, we can write it at the end of the program. So the writing for that syntax is this address is given, location counter value is given, then star symbol is used to indicate that this is a literal port, and then the literal value is given. The location counter value, then star symbol, then the literal value is given. In some cases, it is placed at some other location in the object program. Normally, the literals are placed at the end of the program. Instead of that, we can place the literals or the literal pool in somewhere else in the program. To do that, we have to use the assembler directive LTORG. This is important, LTORG assembler directive that is used to place the literals in some other location in the object program. So this is the usage of that one, LTORG. Then we can give the literal definition. Whenever the LTORG is encountered, it creates a literal pool that contains all the literal operands used since the beginning of the program. So literal pool means nothing but this definition of literals, definition of variables or definition of constants normally we do at the end of the program in an assembly language. Similarly, whatever literals are used in the program also we will define at the end of the program. Instead of that, if we want to define those literals in somewhere between or close to the instructions, we can use this assembler directive LTORG and give the definition of the literals. Next is the recognizing duplicate literals. So how we will identify the duplicates? We can just compare the character strings. If x051 literal is there, another x05 is there, means we can just compare and find that it is same. So duplication can be avoided. Otherwise, we can generate the value and then compare. For example, the literal CEOF, and this EOF hexadecimal value is this one, 45, 4F, 46. So this can be, the generated values can be compared and both are equal, so only one is required. Another usage of literal is it can be used to denote the value of the location counter. For that purpose, the star symbol is used, the current value of the location counter. For example, base star. Base is as an assembler directive. Then LDB star means, the star here means the current value of the location counter. LDB star means the base register is loaded with the current value of the location counter. So star denote the current value of the location counter. Such literal operands will have different values in different places because the location counter value changes. Now we can see how the assembler handles a literal. What the assembler does. So assembler creates a literal table, like sim tab. Assembler creates a lit tab, literal table. It's again a hash table, and this table will contain the literal name. For example, if a literal is used, its name will be there and the corresponding value will be there, and length and address assigned to the operand also can be stored in this literal table. It's a hash table using the literal name or value as the key. Handling of literals by the assembler. Assembler, we know that it has two passes, pass 1 and pass 2. So during pass 1, the assembler enters the literals and the corresponding values to lit tab. That is, when pass 1 encounters, the literal encountered is searched in the literal table. If the literal already exists, no action is taken. If it is not present, the literal is added to the lit tab, leaving the address unassigned. When pass1 encounters an LTORG statement or end of the program, LTORG statement, after that the literal pool comes, or the literal pool will be at the end of the program. At that stage, the assembler makes a scan of the literal table and assigns the corresponding address value to each literal. As addresses are assigned, the location counter is also updated. Then during pass 2, the assembler searches the lit tab for each literal in the instruction and replaces it with its equivalent value. Thank you.